Hello and welcome to our Tips and Techniques videos. I'm Mark Biasotti and we are currently in our advanced modeling episodes. And over the next 30 minutes or so, we'll be exploring how you can increase your skills using some of SolidWorks' more advanced features so that you can be more productive and create higher quality models. So whether you're a seasoned SolidWorks user or a beginner, we think that you'll learn something new in this series. For your convenience, we've listed the topics in the YouTube description that we'll be covering in today's episode, along with a timestamp for each topic in the video. Feel free to skip ahead to any tip or point you want to learn more about. This series is being brought to you by Spanner Product Development, a product development company dedicated to creating positive impact in the world, merging innovation, sustainability, and responsibility to bring meaningful experiences to life for over hundreds of clients. If you want to learn more about what Spanner has to offer, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Now let's get started with this episode of our Advanced Modeling episodes.
Welcome to this episode of our SolidWorks Advanced Tips and Techniques series. Today we're going to do a deep dive in how to model a computer mouse. And I've picked this example because it is an actual mouse that is in production. It is rather complex, and I think it presents some good challenges for us to explore some of SolidWorks' advanced modeling features. So with this episode, I will start off by just strategizing a bit on how we'll approach this problem of modeling this mouse. And then most of the episode will be a hands-on of how to actually create these features, how they interact with each other, and building up the mouse until we have our completed form. So let's get started with introducing this mouse. So this is a Logitech MU007 wired mouse, and I have one of these here on my desk, and so I've got a good physical reference, but I've also have some images from their website that I'll show you how we can use these as reference when we just start our exercise. And with this mouse, there is a way to take a look at it to strategize an approach. And that is, how would we actually model this form? It has really only one flat surface on it, and that's the base that I know of. So as you know, with SolidWorks and basic solid modeling, this kind of exercise is going to require that we do surfacing. And for any of you that have done surfacing, you know that it's generally an exercise of building up design intent through various patches that then to come together as one complete form. This slide shows how I've approached the problem, and you can see that I've prioritized these as we'll step through the model. So starting with the base surfaces, this is a planar surface the mouse is actually contacting the tabletop with. And it's important to start with this because perhaps this is where the profile of the printed circuit board lies, and it is a good base reference for building up the rest of the mouse. There's also some pretty rudimentary surfaces here. And then from this point, it's just a good starting point. So from that, then I will step through the various surfaces that we'll use to complete this form. And that's mostly boundary surfaces. There's a few variable fillets in there. There's a fill surface. And then finalizing with some button depressions, which are also boundaries. So it represents a good set of the type of tools that you would use in SolidWorks to do this kind of product. So it's also important to really understand what are the important aspects of the completed design. And for a shape like this that is highly continuous, it's important to realize that most shapes like this have a flow of direction. And in this mouse, it's really from the front to the back. So we want to really make certain that our connection between surfaces in this direction are C2, or at least really strive to make them C2, so that visually we get that flow from front to rear of the mouse. In the other direction, going from the left to the right side of the mouse, it's maybe not so important because we actually have some C0 or creased edges there, and then we have this stylized fading edge on the top, on left and right sides, as well as the creases that make up the button depressions. So it's just good to keep that in mind as we model and know where we want to really emphasize really good connection. So at this point, I think we'll just jump in and go ahead and start executing on this mouse and build up these various features to our completed form. So this is our completed multi-body mouse part, and you can see over here in the feature manager that I basically have folderized various sections, reference materials along with the base surface, and then the main form features that make up the mouse, and then a shell, and then the final features. We're going to concentrate mostly in the main form features area for this webcast. So let's go back, let's roll back to our reference features and just start with those. So with this design, I have a bunch of reference features. I have the physical mouse, as I've mentioned, but I also have some images that I've grabbed from the mouse's website, and you can see them laid in here. If we start with this first image, this was actually because I wanted to get a very accurate base profile of the mouse, not just from images but from an actual physical mouse. So I just took a piece of paper and rubbed a pencil over it to get that very hard edge, and then measured it as accurately as I could. And then I use the sketch picture scale tool, as you have seen me use in previous episodes, to get an exact size for that. And that really becomes my first reference for this model. And then from that point, it's just a matter of taking and building up a number of other images that show the bottom side. Here's a bottom side image, a top side image, and we'll just hide these as we go. And then the left side image and the right side image over here. So completing with a front view. So from those, that gives me a good reference and basis for starting to build up the mouse. And it's always important. These could be industrial design sketches if we're starting a new design. It could be a 3D scanned image, which is always a great reference to build from. But for this episode, I have the actual physical mouse that I also have measured, and that's where I've put in some references here to actually get the picture's ratio correct with the actual physical dimensions of the mouse. So my actual first feature of this mouse is a sketch that defines the boundary of the planar base of the mouse. So with that first sketch picture, I've tried to accurately draw a style spline excuse me, that defines the outer boundary of the bottom of the mouse, and then a simple 2-point spline for the front surface. And with that, then I can take and make my first feature, which is this planar surface. So from that, we have a really good basis for starting. And as we move forward, then we start to create some other features. Now here, for the sides, I've just taken that edge and created a ruled surface that is tapered to the top plane by a 32 degree angle, and just given it a kind of arbitrary 10 millimeter distance. And then for the front, we have a slightly different surface that I'm going to create for that. But before we do that, then from a side view, if we're looking at our left side sketch picture, we want to trim that ruled surface at a slight angle. And here I have determined that it is just a very shallow 1.5 degree angle coming from the front, back, and with that we go ahead and trim our ruled surface. And then moving along, we want to establish our front curved surface. Now this ends up being a bit more complex because it is not just a ruled surface, but it is a more complex surface that's driven with the upper edge. And if we showed this curve that I created, which is a curve by two sketch entities, so from the top view we have, let me just roll back and I'll show you. So if we roll back to this point, or roll into our feature that is, and show these sketches. So using my reference pictures again of the bottom and top, here I want to look at the actual bottom, and I've adjusted these for some differences in the actual photos that aren't, they're skewed a bit because of perspective. So measuring the model, I've created a couple sketches. One from the top view of a simple 2-point spline that creates the bottom, excuse me, the bottom edge. And then from the front view, I've created another one using our front image of our model to create that curve in that view. And then with those two, I can then use the curve by projection of two sketches to get our resultant curve, which is right here. So let's hide our sketch pictures. And then with those curves, we create a boundary surface that now establishes our front kind of tapered arced surface. From that point, we do some extends of that surface and some extends of this other surface, and then do a mutual trim, or actually I'm just trimming by one surface because I'm not going to use this surface just yet, or this resultant edge. But with that, we have established our base surfaces for the mouse that are fairly rudimentary. They're not as complex as the boundary and the fills that will come later, and they're pretty easily controlled through sketches. Now that we have some of these base surfaces and edges defined, we want to define another important design intent, and that is the curve that runs along the top of the mouse that is rather sharp at the front of the mouse and then fades to the back. And there's a left and a right side curve that are very important design intents. So let's work on the right side curve. So we'll turn on our right sketch picture, and then move to that side of the mouse, and we're going to create from the right view our first sketch. And you can see that I've done some adjustments in the physical mouse with dimensions that differ slightly from the sketch pictures, and as well as in the front. Here we have a 2-point spline. I like to use 2-point splines when there is no interim point involved. They're very easy to control and very smooth. And with that one, then we'll go to the top view and turn on our top sketch, and then do our second curve here. And as I zoom in, you can see that I'm trying to follow along with the mouse itself. And again, there's some distortion in the ratio of the actual image, and I'm adjusting for that with the physical mouse. So with those two established, let me just show that. Also, it's important when you're doing a curve by 2 sketch projection that the endpoints be lined up with the first sketch, and that's what I'm doing here with some construction. If I rotate my view, you can see that happening here. So with that, we can create our 2 projection curve, and you can see it running along the top here and towards the back. Now we're going to do much the same with our left side. So again, if we turn on our left side view and create a sketch that follows that perimeter along the top left edge, and then again with our top view, we'll create our second sketch, make sure it's aligned to that first sketch, and with that we have our second top curve. So if we just show these two, you can see that now we've got some good references for creating our surfaces which will bridge between these curves. Moving forward, I've created a plane from the front default plane that is approximately midway through the mouse, using some construction geometry with my sketches to establish where that plane is. And with that, I want to create an arc that represents the section midway through the mouse at the apex. So with that, on that plane, I've created this sketch, which is simply a 3-point arc. And this mouse is not symmetrical, as you can well tell now. It slopes more to the right side and is higher on the left, but it is rather pretty much an arced profile. So with that, we can get right into our first surface feature, because now we have the basis for creating our top. And that is a boundary surface. So with that boundary surface, we have used the arc that I just created right here as my second direction, along with the edge of that front surface as the second curve in the second direction. And then the actual curves I've created are the first direction, those very distinct edges of the top of the mouse as it wraps to the back. And it's a very simple boundary surface. There are no in conditions. Everything is contact. And I wanted it that way, to be a very uninterrupted, rudimentary surface as our first feature. And so you can see also I'm trimming by our first direction, because I'm only really interested in doing this forward half. We don't want it to extend all the way back to the end of the mouse, because we have a different cap surface in mind there, as well as the transition. So there is my first surface, first boundary to create and establish the top of the mouse. Now that I have that top surface of the mouse, I want to create my side surfaces, both left and right. So before I do that, I need to actually establish a boundary midway through for those side surfaces. So on that same plane, I've created a sketch with these simple 2-point splines, and looking at my model and measuring and doing cross sections with the physical mouse through these areas, I've established these curves. Again, 2-point splines, turned on curvature so I can see that I'm getting a good continuous transition both on the left and the right where this scallop is. And then with those, we can then go ahead and create our left and right boundary surfaces. Here we're starting with the left side, and let me just remove my materials so that we don't have those confusing us. So here we have our right side boundary surface, and it is using again the sketch I just created. It's a group because I've created 2 sketches in one feature, so whenever you do that, it automatically, the boundary switches to the selection manager to be able to do that. So that's how I can do that. And then using, again, on the first direction, second curve, that front edge of the boundary I created for the front of the mouse. And then reusing the curves for the second direction, and then the edge along the ruled surface for the second direction, second curve. Again, I'm using trim by first direction to just get the surface I want. And then the left side of the mouse is pretty much a repeat of what I just did on the right side. Again, here's my surface, using those curves. Everything is contact, no tangency. Moving on, I'm going to now establish the radiuses that run along this left and right top edge. Before I do that, as a surface body, I need to knit all 3 of these together. So I've just very simply taken actually all of my surfaces and knit them together along with the bottom. And then I can apply some variable fillets to the left and right side. In this case, the design, because I'm going to continue this quasi-radius out into these surfaces, I've used a straight transition versus a smooth transition because I want it to continue on. And this is simply a 1.5 millimeter radius in the front, and then slightly growing to the rear to 2 millimeters here on the left side. And then it transitions much faster on the right side. So I've made this 4.5 and then just did some slight adjustments to some of these values to make it look more continuous. And from that point, we can start moving to the rear of the mouse and taking a look at that cap surface. Now things will get interesting as we move to the rear of the mouse and things become more complex. So in the rear of this mouse, we need to take what we've already established and transition it very smoothly to this rear edge. And in addition to that, there's an important design intent here in this mouse, and that is on the very rear of this surface is this capped area. And if we just roll forward in our model and show that, and I just hide the reference surfaces here that I'll talk about in a second, we have this rear cap surface which is very continuous, and it becomes the palm rest for your hand. And so it's pretty important that it be of good quality. And really with this kind of surface, as it is a 2 or 3-sided surface, here it needs to be done with a fill versus a boundary. and I've talked about that in previous episodes. So before I do this fill surface, as you know with fill surfaces from what I've already shown in previous episodes, is that they work best when you can constrain them to tangent boundaries, and that is reference surfaces. And almost all my models use reference surfaces when I'm using fill surfaces. So that's what these two boundaries are about, surface 20 and surface 22. If we roll back to these, we can just show how these are done. So when I do reference surfaces, they're always the same. I do them exactly the same way almost all the time. And basically they are created with two sketch entities. The first is a 3D sketch that is basically a few lines that are constrained to some existing curve geometry. Here I have three 3D sketch lines that are constrained to these current sketches. Tangent, they're all the same length. Very quickly, the idea is just do it really quickly, right? So I'm just using these 3D line entities to do that. And once I have those, and with the existing geometry, then I can create my reference surface, which is basically just this ribbon surface using those 3D line sketch entities in the first direction, and then this existing edge for the second direction. And as you know, with boundary, that's the great thing, is that you can actually use mixed numbers of curves in first and second direction. So that's my reference surface for my fill. Go ahead and show that. And then my first one here, which is 19, goes along the top. And it's very much the same as what I just said with my other reference surface. I have basically three 3D sketch entities here, here, and here, and constraining them to current sketch geometry. And then I create my ribbon surface using those along with the existing edge in my second direction. Okay, so with those I have everything I need to be able to create my fill surface. Now, the first time I did this, there was some experimentation that led me to the final result, and I've been doing this for 30 years, and these models will always require experimentation, no matter how experienced you are. This one I first tried to do as a single fill using this edge and this edge with a constraint curve. So if we go ahead and just make that constraint curve right here, which is actually just derived from this previous curve. Whenever you're doing constraint curves and fill, they can't extend beyond the actual fill surface itself, or they won't work, or they won't work correctly. So that's why I just had to basically, with this sketch, do a convert entity on this current existing sketch and then trim it back or pull back its point to here. So with that, we can go ahead and just try this. So using these existing edges, and then again here I'm doing a select other because we actually have two surfaces on sharing that same edge. I actually want the surface 20 instead of the underlying edge. And then again here I'm going to use select other to also pick 20. And if we apply to all edges tangency and then show our curves, and we have that little curve right there I made. Again, I use select other to pick the correct curve, which I believe by number is 52. And there we've used that curve as the interim constraint for that fill. And we go ahead and fill. Now, looks pretty good, although if you turn on curvature, you see there's a slight bulge in this area. You can see it with the real view a bit, and you can also see it with some reflection. But if you turn on curvature, you can see it right here. And it's having a problem with this corner. I'm not sure what the issue is. It maybe is that these are not quite aligned in the way that it wants to be, even though they theoretically are tangent. We can go back into the fill and we can try a few things. We can turn off optimize surface, which will help a bit. It's a different algorithm for the way it solves these surfaces. And we can also bring up the resolution a bit. But with those, I've found that it really didn't help the situation too much. You can see there's a little bit of a ripple through there. So what I decided to do was, based on experience, is to build this rear area. Let me turn off my curvature here. To build this area as two fill surfaces. So basically divide the problem in half right through the middle. And that got me a better result. Before I did that though, we have to apply a split line right here so that we can actually use these discrete edges for individual fills, both left and right. So with that, I'm basically now creating a fill surface on this right side of the mouse using this edge of my reference surface, using this edge of my split reference surface, and then that curve I created. And furthermore, it's not actually that sketch, but it's yet a third reference surface. So if I show that, I now have a completely constrained by tangent exterior reference surfaces fill surface that's being driven by those. And that is the best situation that you can get for fill to get a predictable result. So that's what I'm doing here. And if you can complete that and then turn on my curvature, you can see that that problem goes away. Now we have a bit of a problem down here again, but it's not that noticeable in the final result. And when we knit to the other side, it kind of goes away. So let's go ahead and move forward, and all we're going to do is just do the exact same thing on the left side of the mouse. Again, let me turn off my curvature, and we'll create our fill right here. Again, using the split reference surfaces and then the existing edge of that previous reference surface. And there we have our capped surface for the rear of the mouse. Now we come to building our transition surface between the front of the mouse and our rear cap surface. And this is the one we need to be really careful with, because we want to make sure that things are very continuous between both these areas. And let me just forward into that actual result. Here we have the boundary surface that's created between those. But if we roll into it, let's take a look in more detail of the curves that make up the second direction. So let me roll forward to about this point, turn on some curves, make sure that we're showing all of them. So we have established our first directional curves, and those are basically the edges of this area and the edge of our cap surface. Now we need to create a few more curves to help it be able to transition nicely from one surface to the other. We have established already this primary curve that's going through the top, and we can use that. But what we have left to do is to establish curves that transition from this fillet and then back to this cap surface. Now we can't use this actual curve here, because after we've applied our fillet up here, it's not actually lying on the surface anymore. So we have to create an additional curve, which is a 3D sketch curve that pretty closely mimics the existing curve that is the design intent. We've established it being pretty much on center here, and I like to use a constraint that's a little more robust than most, and that is the face tangent to face or curvature to face. And the way you do that is by holding down your control key, selecting one end of the curve, and this is a style spline, by the way, then picking the edge with your holding down your control, and then the face, you'll get one of these two options. I'm going to go with equal curvature, and that seems to work better than if I were, for instance, constraining this down to this edge and making this curve and this curve C2. You can see it over constrains. And oftentimes it does with 3D sketch curves. Let me roll back to where I was. And then I'm doing the same thing here, the same method, picking the curve, picking the surface edge, and then the surface itself, and applying C2. Okay, I already had applied one there, so let me undo that. The advantage of that, one of the other advantages of that, is that then you can actually slide these points and they stay tangent kind of in the direction that they were established, which is nice. So you can see that in my left view, I'm basically, pretty much following that curve as closely as I can, and I can do a bit more of an adjustment there to get it closer, but basically I just want to have a curve to transition out. I'm doing the same on the right side, the exact same thing I did as I just showed you with those two curves. And then there's some additional curves that I put in after I've created the transition surface and felt like I needed to get a bit better continuity in these regions. So I've then established two more 3D sketch curves using a 2-point spline, but using the same constraint method, clicking on the curve, the surface edge, and then the surface itself, and applying curvature. And by the way, I'm doing curvature on the beginning and end points of all of these because, as I mentioned earlier in my episode, I really want to make sure there's some really good flow and continuity going between these two existing surfaces. So I pretty much have all my curves. Here you can see them if I highlight them. And now I want to go ahead and create my boundary. So the boundary itself is established by using these existing edges of these existing surfaces as my first direction, and then in my second direction these various parts of sketches and newly created 3D sketches that I created in these regions. So with that we get some pretty good control. Now you can see that I've applied curvature to face here, and if I just reapply it, it gives me a little error. That error is because boundary is a very exacting feature, and if there is any region on this boundary that's not tangent or is not C2, it'll tell you. It doesn't mean that it can't create it. It's just warning you that there's something here that isn't C2 in its connection. In addition to what we've established here, if you want to try to get a little better flow, we can use connectors. So we have an unusual situation here. If I turn on some analysis tools in my boundary, so if I turn on some mesh, you can see that our mesh is going in a pretty good direction between the two surfaces, but here we're needing to take something that's at a high rate of curvature and then go to a very low rate of curvature, and then that becomes sometimes an issue for boundary and trying to decide how these isoparams are actually going to flow. So if I don't want this isoparam here to flow as constant as it is right now, I can create a connector, and let's create two connectors here and here. And if we take those then and start to spread them more between these two areas, you can see that now we're affecting the flow of this area in the way that these isoparams are moving from the beginning surface to the end surface. And that becomes apparent when you solve for it. You can see that now we've gotten a nice blending from the front to the rear, and that takes some experimentation visually to figure out what you need, and you can't actually get to them with the selection manager on. So here I'm just gonna experiment a little bit more, and if we want to, we can create a second set of connectors here. And they might not be necessary in this case because we're really we have a very simple curve that finishes, and the boundary or the connectors might not be influencing it that greatly, but they can help. So that's why I'm putting it in here. Okay, so now you can see with the reflection that we're getting a pretty good rate of curvature. It's not perfect. With SolidWorks, there's a limitation to how good you can get the curvature, but from a display like this, it's pretty good. You can see that we get good blending, and that means that we have something that's a pretty good C2 connection as our transition surface here. Now we're at a point where we've defined the primary form, and with that we can just simply start to knit all of these surfaces together and create a solid model. So for the first time here we have our solid, and we have one final feature to create, or actually two of them, up in the button areas that complete our primary form. In these areas for left and right mouse buttons, we have what I call scallops or concaves, and it's a subtle feature that fades from the front to the rear, as you can see in this photograph right here. We need to mimic that same type of detail in this mouse. So the way that we're going to do that is to create what I call a sub-feature. So we didn't make it part of the primary form, but it's a secondary design intent that's built into the top surface of this mouse. And we can start that feature by creating some split lines from the top view. And these are simply just a 2D sketch on the top plane that creates some offset geometry here, a 2-point spline here, and then some line geometry and arc geometry to create those boundaries for where we want the concaves to live. So with that, we've split those areas. And now we're going to just delete the faces. And we're no longer a solid model, but a surface model. And with that, we can now create these interior surfaces with these kind of fading creases that go from tangent to crease to tangent. And they're fairly simple boundary surfaces with a somewhat complex sketch here in this region. So we're going to establish this as a boundary surface. This is going to be our first directional curves here and here, and with the interim curve that we're going to establish as a sketch. And then our second direction will be simply these two edges. But with this sketch, we basically have used an intersection curve to derive tangency to the existing surface here, and then created a arc with actually 3 arcs with a fit spline over it. So if I just delete that fit spline temporarily, you can see that we have an arc here that is made tangent to this existing edge, and then a larger tangent arc that's tangent that makes our concave by 1 millimeter deep, and then finishing over here with a small radius connected to that. And those are basically a 1.5 millimeter radius. So with that 3D, let me just exit out of that sketch. We did a fit spline over that. That was important, by the way, is with those 3 sketch arcs, I created a fit spline over it, so it's just one continuous curve fitted. And that way I think we're going to get a better result by doing that. So with that, we have the basis for creating our boundary surface. And you can see the isoparams are moving in this direction, that they are getting slightly bigger towards the middle and then smaller as we go out to the rear. And the result is we're going to get a creased shape that disappears at the rear and disappears in the front, and is more pronounced towards the middle, because we're going from these 3 curves. And again, because of the design intent direction, we're going to make this first curve and third curve curvature to face. And we get something that looks like that. So with that, we can move on to do exactly the same thing for our right mouse button. So again, it is this interim curve that's created and then used in the boundary as a 3 curve in the first direction, and then these existing edges for the second direction boundary. So with that, we can just go ahead and knit, and if we actually turn on or turn off or not display our tangent edges, you can see the result is something that looks like that. So that's how you do creased edges on consumer product forms like this. Let me just view again our tangent edges. And we've created some split lines here for our style edges that are part of the design intent of this. There's a metallic stripe going down the right side, and then there's a part break in material right here. So this is simply just splitting the surfaces to create those details. You can see by doing that, though, I've created an unwanted edge right here, so that's an easy problem to fix by just doing a delete face on that area. And then There's a little bump in the beginning or the front edge for the mouse cord. It's just a simple extruded arc that's merged into the solid. And then we can go ahead and shell. I'm just shelling without removing a face because later on I'm going to split the part out. And the rest of the features are fairly rudimentary for creating other details on the mouse, but the hard work is done with the main shape of the mouse itself. So the rest of these features are fairly rudimentary, as I said, and I just roll through the feature manager. We're just creating some more details, so feet on the bottom, and then we get into the scroll wheel itself, cutting the hole for it, applying the fillets to the wheel, also creating the parting line between the two buttons, and then the parting lines down the left and right side, which these actually on most of these modern mouse, these are actual living hinges that are built into the top housing. So their hinge stops right there. And then some drafts for those sidewalls, a little bit of cleanup, just kind of moving down. We're just cleaning up and making some split edges for some of the details or the CMF details of the mouse. Creating this top function or toggle button for the mouse wheel. And then I'm going to create these side buttons by protruding through to the side wall a hole and then protruding a boss that's offset from these surfaces. Creating some reference geometry for building out this face, which is a rather complex face, using a fill here with some constraint curves, and then replace facing that to have this kind of two bumped function button. And some more parting lines between those buttons, adding some fillets to their edges, adding the cable, and then splitting the area for the cable right here underneath, and then combining back with the bottom housing. And there you have it. There's our mouse and the features that are used to create it.
Thanks for tuning in to today's episode. We hope what you've learned has been informative and can help you to better use some of SolidWorks' advanced features. You'll see in the YouTube description a link to example models used in today's video. Feel free to download it, and you can explore these techniques at your own leisure. Also, we'd love to hear from you, so consider emailing me at the address you see here on the screen. If you need help on your design project, or just want to know more about us, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Take care.